Okay, so this video we're going to see if we can do it all in one. So we're going to compare and contrast the sympathetic division of the ANS, the parasympathetic and the somatic, as well as their points of origin, number of neurons, locations, neurotransmitters, all that fun stuff. So we might break this into 2 videos. Okay, so first you have your nervous system. Okay, and that's broken up into 2. You've got your central nervous system and your peripheral nervous system. The CNS is our brain and our spinal cord. Our parasympathetic nervous system is our, peripheral nervous system is our somatic nervous system, and then our autonomic nervous system. And then our autonomic nervous system is further broken up by our sympathetic and our parasympathetic. Somatic nervous system. This is voluntary control. That's really all you need to know. Autonomic is involuntary control. Okay, so your somatic nervous system, it's voluntary control. It uses acetylcholine. They don't have a ganglia that they synapse in. Your autonomic nervous system is involuntary control. So like somatic would be like muscles, right? It's muscle contraction, it's sensory. Autonomic nervous system has involuntary control, things you can't control, heart rate, blood pressure, dilation, stuff like that. Okay, so let's get a deeper look into our sympathetic system and our parasympathetic. Alright, things to know. This synapse, do like a little compare and contrast thing. Fun. Okay, this thing synapses in the 2 places, the sympathetic chain ganglion or the collateral ganglion. The parasympathetic is going to synapse in the terminal ganglia, whichever. Okay, number of neurons. My handwriting is so awful, I'm laying down. 2 neurons, typically. This one does have an exception. Cranial nerve 10, I think that's 10 is super important. It's the vagus nerve, does like 75 to 80%. Our parasympathetic is known as our cranial sacral system because it originates from the upper vertebrae. That's where it comes out of the spinal cord, as well as the lower vertebrae, whereas your sympathetic is in your thoracic area, and so that one's your cranial sacral. What else? Number of neurons, location, neurotransmitters. Parasympathetic usually uses acetylcholine. Sorry, my friends are texting me about conference. Sympathetic uses norepinephrine or epinephrine, although there are, of course, exceptions. There's always exceptions. Okay, this is for the receptors. These are going to use muscarinic receptors, type 1 through 5. These receptors are alpha 1 through 2 and beta 1 through 3. So those are the receptors that they use. And now let's go into the actions. So we're going to have more drawings. This is really ugly, but you're just going to have to get the idea of what we're going for here. Okay, this is my sympathetic nervous system, parasympathetic nervous system. Okay, so acetylcholine is the first one that's released in all of these, and the receptor is nicotinic type 2. Acetylcholine, and nicotinic type 2. This one only has 1 neuron. This goes to the adrenal medulla and it releases epinephrine, into our blood. Okay, this is going to release norepinephrine and it's going to go on to our target organs. So it's going to go to our heart, it's going to go to our lungs, and it's going to go to our abdomen. This one right here is generalized sweating. Okay, and this releases acetylcholine. These are both the exceptions, the like special ones in the sympathetic, because they do release acetylcholine. And the receptor for this is going to be M3. And the receptor for up here is the alpha 1, alpha 2, beta 1, beta 2, and beta 3. These are called your adrenergic receptors. Okay, down here for your parasympathetic, you're going to release acetylcholine for the first one with N2. You're going to release acetylcholine for the second one on all of your targets, same things as those. Parasympathetic does not go to your blood vessels. Doesn't affect that. And it also does not do sweating. Okay, the receptors for this are M1 through M5. These are called your cholinergic receptors. Okay, some important things to note is odd receptors are excitatory. Evens are inhibitory. So we have our heart, we have our lungs, we have our eyeballs, and we have our blood vessels. Okay, on your heart, you're going to have beta 1 and M2, and on your lungs, you're going to have beta 2 and M1. So odds are excitatory. So beta 1 is excitatory, so it's the sympathetic because it's a beta, so it's going to increase your heart rate. All right, your heart is going to beat really fast. M2 would be inhibitory, meaning it's going to slow it down, and that's parasympathetic. Opposite over here, M1 for your parasympathetic is going to excite, so it's going to constrict, and beta 2 is going to cause it to dilate. Over here, you've got alpha 1 for your sympathetic, and you've got M3 for your parasympathetic, and then over here you have alpha 1. So again, this is just sympathetic system. It's going to decrease the diameter to increase your blood pressure. If this is activated, it's going to cause dilation. If you're running from a bear, you want to see. And if you're rested, it's that, whoa. Oh yeah, these are both excitatory. It's going to constrict. Okay. So those are the examples and the actions. What else did I go over? Cholinergic and adrenergic. I already talked about those. What happens when neurotransmitters rise? Yeah, so that's what happens. So when it binds to this one, it's going to increase our heart rate. Binds to this one, it's going to decrease our heart rate. When it binds to this, it's going to dilate the bronchi. When it binds to this, it's going to constrict the bronchi. And it's not like constricting to the point of like you can't breathe. It's just saying you're not running from a bear. Alright, I said this dilates, this constricts, and that's going to decrease your blood vessels, which will then increase your heart rate. So if you wanted to if you had a problem, right, then you could block it. So say you have too high of a heart rate, you could use an antagonist. An antagonist is going to block it. An agonist is going to, I'm going to say, excite it, right, because that's what's happening with that. Another thing to note is parasympathetic. Right, we have our little divide. This is my rest and digest, and this is my fight or flight. So with parasympathetic, if the parasympathetic is hyperactive, you could have diarrhea. Whereas if this is super active, you could have constipation. Right, because you're not digesting, you're not putting your energy towards there. So that's all actually for this video. It's a lot shorter than the other ones.